right, let's continue what we were talking about Friday and now do systems using these linear inequalities. Okay, so let's say we have to graph y is less than or equal to negative x minus 2. So we have y-intercept at negative 2. We're going to go down 1, right 1. Get our points lined up. It has an equal to, so we definitely want to include the points on the line. So the ordered pairs that fall on that line make this true. And then if we're looking for all the y's that are less than or equal to the opposite of x minus 2, they're going to lie under this line. Okay. We could double check. We could just pick a point under here, make sure it comes up true, like negative 5, 0. Is 0 less than or equal to 5 minus 2? It sure is. Okay. For the other line, we got a y-intercept of positive 2, and then we're going to go down 5. 1, 2, 3, 4, 5. Right 1. Or up 5. 1, 2, 3, 4, 5. Back 1. Kind of get it lined up. Again, this one has an equal, so we're going to include the points on the line. And we want to be greater than or equal to it, which are going to be these points over here. All right, so I picked yellow and blue on purpose because yellow and blue make green. So I'm looking for the points that are both. So we're looking at this quadrant right here. I say quadrant, I might confuse some of y'all. So maybe this section. And then if I pick a point in there, like right there, 2, negative 5 is in that green section. Is the y less than or equal to the opposite of x minus 2? Is negative 5 less than or equal to negative 4? It sure is. Is the y greater than or equal to negative 5 times x plus 2? It sure is. So the actual solution is that green part. Okay. So next one up, negative 2, down 1. This time there's no equal, so I'll do a dotted line to show that this is the boundary. It's just I don't want to include the points on the line. And if I'm greater, if the y's are greater than the opposite x minus 2's, then they're above the line, which is all this. So any ordered pair in this yellow section, or half plane, makes that first one true. Okay. Other one, down 5, right 1. Also, we could go up 5, back 1. Also doesn't include the equal, so we do a dotted line. We want to be under it, so less than it, which means we're going to be looking back here. And it's this green section is the one I'm talking about. So if we pick a point in there, say negative 1, 1. Is my y greater than the opposite of my x minus 2? It sure is. Is my y less than negative 5 times negative 1? That's 5 plus 2. Is 1 less than 7? It sure is. Okay. All right, so next up, y-intercept of 2, rise 1, run 2. It includes the equals, so I include the points on the line. I want to be under this one because I want my y's to be less than the half x plus 2. Okay. Other line, y-intercept -3. We're going to go down 2, right 1. Don't have an equal, so we'll do a dashed line. We want to be under it. So that's talking about all this. So our solution is this section here. We want to check it. Let's try -3, 0. That looks like a good one. Is my y less than or equal? Ooh, I don't want to do. Let's try. I don't want to half an odd number and mess y'all up. Let's do -4, -1. So is my y less than or equal to half my x plus 2? Is -1 less than or equal to 0? Yep. Is my y less than -2 times -4, which is 8 minus 3? Yep, sure is. Okay. All right. X is less than or equal to -3. So that's just a vertical line. And if I want to be, oh, I messed up. I wasn't paying attention. It's a vertical line, but there's an equal on it. So it should be a solid. There we go. And then less than it. There's where all the x's are less than -3. The line itself represents all the ordered pairs where the x is equal to -3. And then the other line, let's see, y-intercept at 2. We're going to rise 5, run 3. 1, 2, 3, 4, 5. 1, 2, 3. Gets me off the page or off the sheet a little. 1, 2, 3, 4, 5. 1, 2, 3. And no equal there. So dotted. And we want to be under it. So we're looking at this section right here. Probably I could try. Well, definitely -4, 1, 2, 3, 4, 5. -4, -6 would be in there. I know that would definitely work. Let's try. Is the x less than or equal to -3? Yeah. Is the y less than 5/3 the x plus 2? So -20/3 plus 6/3. That's -14/3. -6 is -12/3. That's not true. Plus, what did I pick? Hang on. It may have been too steep. I wouldn't say that. This is definitely over there. Just looking at my graph. Maybe it's not definitely. I definitely might have been a bit presumptuous. How about we try -10? That would definitely be under there because we go straight down. Let's try that. So there's -50/3 plus 6 is -44. That's definitely true. Okay. Yeah, it didn't have enough slope to get. It wasn't steep enough for the -6 one to be in there. Okay. This, we got a y-intercept of -2. We're going to go down 5, right 3, or up 5. 2, 3, 4, 5. Back 2. This one. Oh, and we want to be less than or equal to. So we're going to be under that line. other one, y-intercept of 2, down 1, right 2, back 2, dotted line, because, oops, I definitely run a little crooked right there. Okay. Be less than it. I'll extend this to make sure you can tell that it's all green out here. So we're talking about this section here. Okay, this last one, rise 2, run 3. It's got the equal to. I want to be greater than it. X, Y, intercept -3. I'm going to go 1, 2, 3, 4, 1, 2, 3, dotted line. Greater than it. Now remember, I'm assuming Friday's stuff made sense because I'm just jumping straight to where our graph is. If it didn't, you need to come see me and get some help. But there's the section that represents all of our solutions. So this section right here.